You guys want to give it a shot? So I have 3 very easy questions, elementary level. See if people could get 2 of 3. You guys want to try it? Yeah, cool. So the first one's the hardest, but then they get easier. And obviously they have to do with common sense. Do you guys trust your common sense? Yeah, you guys should, right? Yeah. All right, so I have 2 images here, and the reason I call them images is because one of them is a photograph and one of them is a painting. So I want to see if people could tell the difference between the photograph and the painting. This is the painting. You think this is the painting? Yeah. And so you think this is a photograph? So you think this is a photograph?
Yes.
Yeah, and you think this is a photograph?
Yeah.
Okay. What was the trick question? They're both paintings. Yeah, so this is an oil painting and this is a digital painting done on an iPad. So I don't expect people to get this one because obviously it's impossible to tell the difference, right? So there is 2 reasons why I asked this question though. The first reason is just believing someone opens the door to being deceived, right? Because you believing that one's a photograph, that influences your choice, right? That's obvious. The second reason is if we want to determine something is real, an image is not good enough. Because if I showed you an image of me walking on water or me flying, would you believe I could do those things? No, right? You wouldn't believe I could fly if I showed you a picture of me flying, right? That's obvious. That defies physics, right? So these next 2 have to do with elementary physics. They actually have to do with water. But we agree that water, you know, once it's contained especially, it always seeks its lowest point. In other words, it always goes to the bottom of the container. It always goes down. Because if I tilt the bottle upside down, water still goes down, no matter what direction. Water always goes down, right? That's a fact, right? Since we understand that simple fact about water, so I painted the water blue with blue food coloring to make it easier. Since we understand water always goes down, you know, I took this one in 2 different orientations, one upside down and one right side up. So which one of these 2 is upside down? Since we understand water always goes down, which one of these 2, how I'm showing them to you, which one is actually upside down? There you go, you guys got it, perfect, yeah, you guys got it. So this one I actually took like this, because the water can't stick to the top of the bottle, right? That's obvious, you guys got it. So this last one is even easier. Another thing, have you guys ever heard of water always finds its level? Right? What would be another word for level if we had to use a different word?
Parallel?
Parallel, could we say horizontal? Horizontal is actually the proper definition for level, you know? So since we understand that fact about water as well, which one of these 2 represents level correctly when we're looking at the water? A or B? A, right? It's obvious, right? So the real reason I do this is because over 95% of the population, including myself and maybe you guys, have been tricked to believing that this is the answer, even though we know it's this one. You guys want to know how we were tricked? Do you guys believe the Earth is a ball? Right? So NASA in specific, they claim to have satellites orbiting the Earth, right? So they need to know the radius of orbit, so they need to know the radius of the Earth. So they do tell us the radius of the Earth is 3,959 miles. So if we multiply that times 2, we get the diameter, and if we multiply that diameter times pi, we get the circumference. It's basic math. So the circumference of the Earth is 24,901 miles. That's what NASA is telling us. So there needs to be curvature every mile. So the first mile there's an 8-inch drop, second mile there's a 32-inch drop. By the third mile there should be a 6-foot measurable drop or curvature of the Earth, right? So if we were actually go out in nature and build a level structure over a giant lake, we should be able to measure that curvature. So in 3 miles there should be 6 feet of curvature. So in other words, this will be the #1 experiment to debunk the globe, because if we actually went out to measure for this curvature, the water is going to show us, you know, that it's level, that it's going to be parallel to the structure. That's what level means. That's what water does. But they're trying to tell us that water is bending 8 inches per mile squared. But in reality, that's not true, you know. So if I was to ask you guys, what's the #1 proof or thing that makes you believe that the Earth is a ball? Or the #1 reason, you know? Will you say satellite imagery? Yeah, right. What did you say? Gravity. Orbiting. So orbital mechanics, right? Okay, so when it comes to satellite imagery, I don't know if you knew this, NASA actually, and any other space agency as well, they actually don't call them photographs. They actually call them images. And the reason they call them images is because they're not photographs, they're Photoshop. And they admit this. So they don't call them Photoshop, they actually call them composites. So composite is just a fancy word for Photoshop. In other words, they're making them in a computer. So no genuine photograph of the Earth from space actually exists. So everything that they're showing us from satellites, it's all CGI. You guys know what CGI is, right? It's Hollywood trickery. So the only place you're ever gonna see curvature of the Earth, it's, are you guys familiar with fisheye lens, like GoPro lens, right? Fisheye lens actually curve horizontal lines. So whenever you see like high altitude imagery or video, it's usually a GoPro if you're seeing curvature. Because if you use a standard camera, it's the horizon's always horizontal, you know. So how would you guys describe the horizon? So these are images of the horizon. You know, how would you guys describe it geometrically? Exactly, right? Because that's where the word horizon comes from, if you ask me, from the word horizontal. So in other words, we should be able to see that curvature left to right, you know, if the Earth was a globe. Another thing about the horizon, it rises with you the higher you go up. If the Earth was truly curving down, the horizon should stay down, and you should look down on the horizon. You never look down on the horizon in reality. Because the horizon, I don't know if you knew, it's actually apparent. It's actually the limit of our perspective. So it's just how far we can see. That's the limit, the horizon. That's why when you rise up, you're able to see further in front of you because you're increasing the angle of view. You know, you're not, and you're looking further in front of you, not below you. You know, that's another fact about. Have you guys heard of this topic before? Of people that don't believe in the ball Earth or flat Earth, right? You guys heard of that, right? How long ago did you guys hear about it? A few years ago, maybe, right? Yeah. So you think it's a possibility that maybe we were actually lied to about this place, or are you pretty set on that it's a ball, or are you open to the idea that?
I feel like perception is not necessarily always accurate. So like it could be different in like ways that we don't know. Like how like there's like different dimensions, like fourth.
Oh, I heard about the fourth dimension, but to be honest, the fourth dimension, I would say that's like a dream. It's something that's not here in our three-dimensional world, because you know, we have front and back, left and right, and up and down. Those are the three dimensions that we use to navigate this place. What would be the fourth dimension? That doesn't perceive my mind.
So like just because it's like we don't understand it doesn't mean it's not there. So like it could be different, but like I don't know.
All right. So I would say the fourth dimension is just an idea. So even if you're saying like perception, it is a different geometry. How we see the world is different from what it actually is. That's actually it's obvious. But if we could see the curvature of the Earth, we should be able to measure it. Would you guys agree or disagree? If we could see the curvature, we should be able to measure it, right? That's pretty common sense, pretty obvious, right? So that's why, in my opinion, you're never gonna hear anyone talking about this experiment in the mainstream. Another reason why is because it's actually one of them. I would say is the #1 censored topic online right now, and they've been censoring since like 2018, 2019. So the way they're doing it is they're not removing this information from the internet, they're just demoting it. So if you're looking for anything genuine, you're not gonna come across anyone like me talking about this. You're just gonna get nothing but ridicule and experts, just so-called experts, dismissing it. They don't even talk about it seriously. They just laugh, you know, like, oh, I can't believe people believe the Earth is flat, and they just go to the next topic and that's it. So they're just playing on people's emotions basically. So that's why I'm out here, because it is being censored and just giving it to people straight, you know. So I actually do have some information that you could use to cross-reference. You know, you don't have to believe me. Don't believe me, actually. You know, trust your common sense. You know, have you guys ever heard of Euclidean plane geometry? So it's the geometry assumed to construct everything that we see. So from railroads to bridges, they don't take account this 8 inches per mile square. They don't take account for curvature. They assume they do everything from a baseline, from a data map. You guys, I'm pretty sure you guys have seen blueprints before, right? Like it's X and Y, just straight lines and verticals and horizontals. That's a blueprint. You know, there's no curvature in blueprints, you know what I'm saying? So Euclidean plane geometry, again, it's another proof that debunks the globe. So here are the 6 main proofs. If you guys want to take a look at them, you guys could take it home. I have here, you know, I have a few to pass out. And if you guys have a question about one of those proofs right now before you guys go, I can answer them. And if you guys want to check out my channel as well, I have a YouTube channel. My YouTube channel is on this card right here. If you guys want to take that.
Do you consider yourself a flat earther?
So to be honest, flat earther and all that, it's just like name calling. So I would say it's just a label, and I stay away from labels. So I would, if I was to call myself something, you know, like I would just be a realist. That's what I would consider myself, you know, just a realist. I go with physics. So whatever physics shows me, that's what I go with. I don't actually have beliefs.
And is there like available research backing up your claims?
Oh yeah, definitely. That's why I have these links and these websites that you could use to cross-reference. The channel on top is my channel, so you could just check out the conversations I have with other people. Maybe you'll see yourselves on there as well, you know. But yeah, I go to other universities as well, and I, you know, challenge the students on this topic, since it is the #1 taboo censored topic right now. You know, and it has to do with science, basic science, geometry to be exact. You know, this is all about geometry, you know, and basic math. And that's what they're censoring this, because it's very easy to understand. You know, an elementary student can understand it, to be honest. And actually, if I'm talking to children and they completely understand this, they get it, you know. You know, but you guys got it too. You know, you guys understand, you know, the basic math that's behind this, how we could physically measure this, and in my opinion, water is the #1 proof, because the surface of water never bends, like in your bathtub, in a pool, and in a lake. And then the oceans are no different. You know, I'm pretty sure you guys heard of the term sea level, right? And that's how they measured heights and depths. Like, oh, we're 50 feet above sea level, or 100 feet above. It's all done from a datum line, which is a baseline, which is horizontal. You know, that's how everything's congruent with each other. That's how we would have measurements that actually work. You know, spherical geometry, nobody ever uses it. Nobody. You know. So yeah, you guys have any questions before you guys go, or are you guys good, or? Do you guys want to see images of the stars? Have you guys ever seen this, how the stars actually look like? Yeah, yes, real quick. You know, it's just, I have them right here, mine as well, right? So the stars, they tell us that they're trillions and trillions of miles away, right? Light years away, right? These images of the stars were taken using a 83 times zoom camera. So it's an optical zoom, so it's real zoom, it's not digital zoom. So with 83 times zoom, we're able to bring the stars into focus. So that tells us that the stars, the sky, is only about a few thousand miles away. It can't be further than that. We wouldn't be able to bring them into focus like this. So the stars, in reality, nobody actually knows what they are, but they just twinkle every light, you know, every light in the rainbow. And they're just up there. If you ask me, the sky is just a fixed map. Because I don't know if you knew, they actually they reset every year. They're constant. That's why they're called constellations. You guys heard of the constellations before, right? We have 12 constellations, you know, supposedly, because they're constant. They don't actually move. So if we were actually a ball in outer space, we should have a different sky every night. The stars wouldn't reset. You know, if we were actually shooting through space, spinning, you know, around the Milky Way and all that, we'll have a different sky every night. Every sky will be like a fingerprint. It'll be unique. You know, no stars will ever be in the same position ever, but they are every year. You know, that tells us that the Earth is stationary. Well, it's not spinning around the sun. You know, if anything, it's the sun spinning over us. So the sun spins over us like a clock. So that's another big thing about this. Because I used to be atheist. Again, I'm not religious either. I think all religions are there to control, and the heliocentric model is the biggest religion. And the reason why is because all religions, what they have in common is they all offer us a creation story, right? What is the Big Bang, you know, all of the evolution, that's a creation story, just like any other religion. And the reality of the matter is that nobody knows how this place was created, or how it came to be, or what it actually is. You know, for all we know, we're experiencing a technology right now. We don't even know it, you know? Nobody knows what this place is. That's my reason for being out here, you know? I want to spread awareness about that fact. You know, and science proves that. Science proves that this place was created and that we have some kind of purpose here. You know what I'm saying? Like, you guys heard of the first law of thermodynamics? It says energy cannot be created nor destroyed. It can only change from one form to another. So that debunks the Big Bang theory, that everything came from nothing. You know, so science debunks itself when it comes to laws. So we're gonna go with laws or theories. You know what I'm saying? Because again, the first law of thermodynamics debunks the theory of the Big Bang, basically. You know what I'm saying? So yeah, man, I came across this 6 years ago in 2016, and it completely changed my life completely. Like how I view, you know, life in general. You know, everything completely changed. You know, it turned my world upside down, but in this case, it turned it right side up. You know what I'm saying? Because nothing really made sense to me before, you know, but now everything makes sense to me. You know, the fact is we don't know what this place is. That could be a scary, you know, position for most people. Like, oh, people want certainty. That's why, you know, that's why people go to religion. You know, especially when they have a traumatic moment, you know, or something. Because people want certainty. People want to feel good, you know. So I think that's one of the main reasons why people stick to the ball earth belief, because they don't want to like admit to themselves that maybe we have been lied to about this place is, you know. It's pretty big, you know. If you ask me, it's the biggest lie on earth, in what the earth actually is, or in this case, what it's not. So it's pretty huge. Have you guys came across anyone else that, or another flat earther, right? Or another person doesn't know, right? Am I the first one? Wow, that's pretty crazy, because again, in 2016 it exploded on the internet, and then again, they changed the algorithms and everything on Google and YouTube in 2019. So that's why you're not gonna come across anyone genuine like me. And I'm not surprised you haven't, you know? A lot of people that know about this as well, that are in my position, are kind of antisocial. I mean, I used to be pretty antisocial, so I stay away from people, you know. So most people that know this are like that. So they don't have like the guts or the social skills to come out and talk to other people. So I actually had to come out of my shell to come out and do this, because, you know, if I don't do this, I mean, who else is, you know, someone else. I mean, someone has to start it, you know, that's my point. So, I mean, you guys have any questions? You know, any other points that maybe I missed about the globe, or, you know, no? All right, well, if you guys don't have any other questions, I mean, thanks for talking to me. You guys have a good one. Yeah, you guys have a good one. All right, thanks a lot. You guys want to give it a shot? Yeah, nice. You guys are all together?
No, just
Okay, no problem. Okay, so 3 very easy questions, and obviously they have to do with common sense. So see if you could get 2 or 3. So the first one's the hardest, and then they get easier. So I have 2 images here, and the reason I call them images is because one of them's a photograph and one of them's a painting. So I want to see if people could tell the difference. Which one's a photograph and which is a painting?
Okay, it's common sense, alright? That's probably the painting.
So you think this is a photograph?
Sure.
Yeah. You guys want to try, or?
Are they both photographs?
Okay, is that your final choice?
Oh.
Yeah, that's my final choice.
What about you?
Oh, no, this is
Just them two? Okay, you actually were close. It's a trick question, but they're both paintings. So yeah. So this is an oil painting, and this is a digital painting done on an iPad.
I think
So
I've seen a time lapse.
yeah, there's actually is a
seen
time
that
lapse of
one
this one.
before.
Oh, okay.
Yeah, there is
Then I
on
think I've
YouTube.
definitely
It's very
seen
famous,
that,
actually.
yeah.
that type of stuff.
Yeah, so I don't expect people to get this one right because it's impossible. I couldn't even get it. It's obvious, right? But there is 2 reasons why I asked this question. The first reason is if we want to determine something is real, an image is not good enough, right? Because if I show you an image of me flying or me walking on water, you won't believe I could do those things. That's obvious, right? The second reason is just believing someone opens the door to being deceived, because you believing that one's a photograph, that influences your choice. So it's not good to just believe someone, right? So these next 2 are very easy. They're actually common sense. They actually have to do with water. So could we agree water always seeks its lowest point? In other words, it always goes to the bottom and it always goes down. So because I could turn the bottle upside down, but water always goes down. It doesn't matter what direction the bottle is, water always goes down. That's obvious, right? That's obvious. So since we understand that fact about water, I painted the water blue with food coloring to make it easier. Which one of these 2, how I'm showing them to you, is upside down? Since we understand water goes down, which one is upside down? How I'm showing them to you. Very easy. Since we understand water goes down, which one is upside down? Water will be the reference point. If you're looking at the water's going to show you.
Just say your answer.
Wait, but why can't be upside down? But no matter what, water is just going to go to the bottom.
Yeah, so if you understand water always goes down, which one of these 2 images is upside down? How I'm showing them to you.
Upside down. We just upside down. Wait.
He said it's easy.
It is actually. I've had. Okay, yeah, you got it. Yeah, this was it. Yeah, so you do trust your common sense a little bit. Yeah, so obviously the water can't stick to the top of the bottle. I actually took this one like that. So that's the one I had upside down. So you got it. It's perfect. So another thing about water, very quick. This one's easier actually. Have you ever heard of the term "water always finds its level"? Right? What would be another word for level if we had to use a different word?
Still. For water. Stable.
Even or horizontal. Horizontal is actually the proper definition for level. So, you know. So since we understand that fact about water as well, it always finds its level, which one of these 2 represents water level correctly? A or B? It's elementary level. Very easy.
Come on, bio major.
A or B.
Yeah. But he's not even a bio major.
I'm not
Environmental science.
It's elementary physics right here, so anybody should be able to understand it. Hey, obviously, right? A is the right answer, right? Yeah. So the real reason I do this is because over 95% of the population, including myself and maybe all of you, have been tricked to believing this is the answer, even though we know it's this one. You guys want to know how we were tricked? Do you guys believe the Earth is a ball? You guys believe the Earth is a ball, right? Or you guys open to the idea that it might not be? Or if you guys don't know, that's pretty honest.
I honestly just didn't care about the general argument.
Right, but so NASA, they claim to have satellites orbiting the Earth, right? So they need to know the radius of orbit. So they need to know the radius of the Earth. So anything with a radius is a circle or sphere, right? So they do tell us the radius of the Earth is 3,959 miles. And if we multiply that times 2, we get the diameter, right? And if we multiply the diameter times pi, we get the circumference. So the circumference of the Earth is 24,901 miles, what they're telling us. So there needs to be curvature every mile. So the first mile is an 8-inch drop, second mile 32 inches. By the third mile, there should be 6 feet of curvature. So if we actually, Yeah, it's basic math, basic math. So if we actually went out to a lake to measure for this curvature, build a level structure over a giant lake that was miles across, we should be able to measure that curvature of the Earth if the Earth is truly a ball. But in reality, if you understand physics, water in specific, that water is going to be parallel to the structure. You know, that's what level means, that's what water does. So this will be the #1 experiment to debunk the globe, a physical measurement of the Earth. You know, so if I was to ask you guys, what's the #1 proof or reason that makes you believe that the Earth is a ball? Or that keeps you, you know, in the middle, or what was that? Images, right? I'm glad you call them images, because I don't know if you guys knew, NASA doesn't call them photographs, they actually call them images, and the reason why is because they're Photoshop. And they admit to this. They don't call them Photoshop though, they call them composites. So they're basically making them in a computer. It's basically CGI. So the only place you're ever gonna see curvature of the Earth, are you guys familiar with GoPro cameras? How the fisheye lens curves horizontal lines? So that's the place you're only gonna see curvatures through a GoPro or through CGI cartoons, basically, because the horizon is always horizontal. You know, that's where the word horizon comes from. You know, these are images of the Earth, you know, from high altitude, and without a GoPro, it's always horizontal. You know. So you guys have any questions, you know, about this subject before you guys go? No, you guys are good. So you guys want to take some information home, because the reason why I'm out here is because it is being censored. So if you actually try to go and look for some genuine information, you're gonna get nothing but ridicule, nothing but dismissing, just people making fun of it. So especially by experts, you know what I'm saying? But actually have some information if you want to cross-reference. You guys can check it out in your free time.
I'm honestly just too lazy to do that.
I mean, that's honest. That's honest. I respect that. Do you guys want to take some information home, or are you guys good? You guys are good?
It was
Okay,
fun,
sounds good. All right, yeah, it was actually fun for me too. Appreciate that. All right, you guys have a good one. All right. What's up? What's up? So you guys want to give it a shot?
Yeah. I don't trust my common sense though.
You don't?
I don't.
I think you do. You just don't know it yet.
Am I supposed to trust my common sense?
You're supposed to. I mean, if you don't trust your common sense, who are you gonna trust?
That's true.
You're just gonna believe people what they tell you, right? You have to trust your common sense. That's what kept you alive for this long, you know.
But what if your common sense isn't like right? But like, you know, if you just trust it, then you just like going to the wrong path.
Then you're gonna have to show me how my common sense is wrong.
Right.
Yeah, and then once you show me, then my common sense is gonna grow and understand how it's wrong.
Right.
You know what I'm saying?
Then how are you supposed to know that your common sense is wrong if, like, you know?
Well, you have to show me. So this has to do with physics, actually. The first one's actually the hardest one, but then they get easier, elementary physics after that. So the first one's a perception test. I have 2 images. So the reason I call them images is because one of them's a photograph and one of them's a painting. So I want to see if people could tell the difference.
I mean, this one looks more like a painting.
Okay.
I think this one's the painting, because like the lighting's a bit off for me, because like the layering.
Okay. Fair enough. So it was actually a trick question. They're both paintings.
Oh.
Right, yeah. So I don't expect people to get this one right, obviously, because it's impossible. I couldn't even get it, you know. It's too realistic, you know. But there is 2 reasons why I asked this question. The first reason is just believing someone opens the door to being deceived, right? Because you believe me that one's a photograph, that influences your choice. So it's not good to just believe someone, right, on their word. The second reason, is if we want to determine something is real, an image is not good enough. Because if I showed you an image of me flying or me walking on water, would you believe I could do those things? No, that's impossible. That defies physics, right? So the next 2 have to do with elementary physics. It has to do with water, actually. So could we agree that once water is contained, like in this bottle, it always seeks its lowest point? In other words, it always goes down. Because I could turn the bottle upside down, but water always goes down. It doesn't matter what direction the bottle is, water always goes down. That's a fact. You know, nobody can deny that. So since we understand that fact about water, I took 2 images here and I painted the water blue with food coloring just to make it easier, because water is see-through, you know, you won't be, but the water, you know, I painted it blue. Since we understand water always goes down, how I'm showing you these pictures, which one of these 2 is actually upside down?
No, they're both upside down.
No. If we understand water always goes down, only one of these is upside down, how I'm showing it to you. So which one's upside down?
Could you repeat the question?
So since we understand water always goes down,
Yeah.
like in my bottle, always goes down, how I'm showing you these images, which one of the 2 is upside down?
I mean, like, it makes it look like this one's upside down, but like technically you can make it so that this one, if you take the photograph upside down, then this can also be upside down.
Well, if we're looking at the water is gonna be the reference point.
His question is which image is upside down. So it could be like this whole image itself. Not
The whole
Yeah, so it's both not upside down.
Nah, not both are upside down. One is upside down, and if you're looking at the water's gonna show you which one's upside down.
Yeah.
Well, then that's no.
Yeah, you got it. Yeah.
But why?
Explain to him why. Do you?
Oh, because like imagine you flip the table, right?
Yeah.
It looks as from even if it flip it, if there's a background, it looks like the table's like down.
No, I get that, but can this also be up?
No.
No, because like water's down.
Yeah,
Because of
the
gravity.
water. Look at the
Right.
water on this one. Where's the water on this one?
Okay.
It doesn't. The water can't stick to the top
Right,
of the
right,
bottle.
right,
So I
right.
actually took this one like that.
Like that.
Right.
Yeah, you got it, man. You got it. Perfect. So this last one is even easier. And have you guys ever heard of the term water finds its level?
Yep.
Right? What would be another word for level if we had to use a different word?
Horizontal.
Perfect, dude. You got it. That's actually the exact definition of level, right? So since we understand about that fact about water as well, which one of these two represents water level correctly? It's elementary. This one's very easy. It's the easiest one of all. A, right? Obviously, right? So could we say that somebody that believes the answer is B, could we honestly say that they don't trust their common sense?
No.
Right, that's obvious, right? So the real reason I do this is because over 95% of the population, including myself and maybe you guys, have been tricked to believing this is
Because
the
of
answer.
Earth, right?
So do you believe the Earth is a ball?
Yeah, of course.
Yeah, so
This is an experiment.
okay, so NASA in specific, they claim to have satellites orbiting the Earth, so they need to know the radius of orbit. So they need to know the radius of the Earth if they're truly going around it, right?
Yeah.
So they do tell us the radius of the Earth is 3,959 miles. So if we multiply that times 2, we get the diameter, and if we multiply that diameter times pi, we get the circumference. So the circumference of the Earth, what they're telling us, is 24,901 miles. So what that means is that there needs to be curvature every mile. So the first mile, there should be an 8-inch drop. Second mile, 32 inches. By the third mile, there should be 6 feet of measurable curvature. So in 10 miles, there should be 66 feet. That's a 6-story building of measurable curvature. So if we actually went out in nature, like a giant lake that was miles across, and built the level structure over the lake to measure for this curvature, the water is going to be parallel to that structure because that's the physics of water. Water always levels out. It always finds its level. But they're trying to tell us that it's curving 6 feet in 3 miles. So in my opinion, this will be the #1 experiment to debunk the globe, because if we actually did a physical measurement of the Earth, the water's gonna again debunk that it's not curved. Basically, you know, the surface of water always levels out. Like any lake you go to, and then the oceans are actually level as well. I'm pretty sure you guys heard of the term sea level, right? That's how they measure height and depth to be congruent with each other. They do it from a baseline, from a datum line. So if I was to ask you guys, what's the #1 proof or reason that makes you believe that the Earth is a ball?
I saw this experiment where one person had like a pinhole and they shown laser, and then like
3 miles or 6 miles, right?
Like they checked it,
Right.
it didn't like hit the same like height level.
Yeah, it was
just
lower,
went
right?
Yeah.
Okay, so here's the thing about laser experiments, and you're only going to see laser experiments in the mainstream, by the way. You're not going to see a physical measurement.
Yeah.
So, and the reason why is what happens when you shine a laser in water? Does it go
refracts.
straight? Exactly, refracts. So when you shoot lasers through the air, I don't know if you know, the air is kind of like a moisture. There's always going to be refraction. So it's always going to be an inconclusive test. So that's the only test you're ever going to see online, and it's because it's inconclusive. So they just want to keep people confused. Again, if the curvature was there, we should be able to physically measure it, you know, with a ruler, literally, you know, not just rely on light. Especially with refraction going on, you know, it's going to be inconclusive every time, because we can't suck the air out of the Earth. Impossible to actually have this test. So a physical measurement will be the next best thing. If you ask me, even better than the laser experiment. So you're never going to see this experiment in the mainstream anywhere.
Wait, can't you use like you know how there's like tunnel for like high-speed vehicle that sucks out all the air, right, for like 10 miles and so, like the one that SpaceX and thing like.
Right. I would say, I would say, you know, I don't know if you knew this, but there's no such thing as an empty space. So nature abhors a vacuum. Have you ever heard of that term?
Yeah.
You can't suck the air completely out of a cube, for example. You know, it's impossible.
Yeah.
You know, so even theoretically, it's impossible to do that experiment that you're saying.
I guess.
But
yeah.
theoretically, this one is physically possible. You know, we have the technology to build, you know, straight across. So have you guys heard of Euclidean plane geometry? So it's the geometry used to basically build everything we see. So from railroads to bridges that are miles across, everything's done on the assumption that the Earth is a level plane. So they don't take account for the curvature. That 8 inches per mile squared doesn't exist in blueprints. So any blueprint that you see of any construction, doesn't matter the distance, it's always going to be from a datum line. So it's always going to be verticals and horizontals. That's what blueprints are. You know, everything has to be congruent with each other. Because if we actually use spherical geometry, you wouldn't be able to build anything. Nothing would work. There will be no such thing as level. You know. So again, just real quick, how would you guys describe the horizon? So these are images 20 miles in the sky So how would you describe
It looks
horizon?
flat.
Exactly. Horizontal will be the proper term. I mean, I think that's where the word horizon comes from the word horizontal, right? So the only place you're ever going to see curvature of the Earth is through GoPro fisheye lens that curves horizontal lines. I don't know if you guys are familiar with the wide angle lens. Every action camera has it nowadays. And through CGI images or video. That's the only place you're ever going to see curvature of the Earth, because in reality, it doesn't exist.
Yeah.
So in my opinion, NASA and any other space agency that exists, they're just Disney for adults. So it's just cartoons for adults, if you ask me. Yeah, I mean, it's pretty funny, but it's true. Yeah, yeah. So do you think there's a possibility that maybe we were lied to about what this place actually is, or are you pretty much set that it's a globe?
Yeah.
Or are you open to the idea? That
Yeah, I'm open to the idea.
yeah, I'm glad you have.
Yeah.
How long ago did you guys hear about this topic? Have you heard about this topic before?
I mean,
Flat Earth, right? Have you heard of Flat Earth?
I've heard of Flat Earth.
Yeah, right? How long ago did you guys hear about it? If you don't mind me
I
asking.
don't know. I watched a YouTube video.
Yeah.
Like, when I was going, and, like, I thought this experiment, like why people like try to like launch the rocket and like try to figure out where they landed.
Yeah. So yeah, there's a lot of I would say there's a lot of misinformation as well.
Yeah.
I would say the laser one is kind of not completely misinformation, but again, it's kind of to divert. You know what I'm saying? There's even a Netflix documentary where they do a laser. I don't know if that's where you've seen it.
Maybe yeah.
Yeah. So anything real is not gonna be on Netflix. That's for sure. You know what I'm saying? they just say that. And then in 2019, I came across this in 2016, and it wasn't really censored online. In 2019, though, that's when they changed the algorithms. YouTube was shut down for like a week as well. Nobody could use YouTube and it's because they were changing the algorithms from Google and YouTube, so that anybody trying to search for information like this, you're just gonna get nothing but ridiculing videos, and all these experts are just dismissing it, not even taking it serious.
Also, flat Earth theories are also censored.
So the way they're censoring it is, again, with misinformation. So they'll have these fake flat earthers, you know what I'm saying? I don't consider myself a flat earther, I'm a realist, because flat earth, it's just name calling. It's just a way to group people into a group and just make them look crazy, you know what I'm saying? So I'm not a flat earther,
right?
I'm a realist. So, but yeah, they're using this term flat earth and flat earthers just for name calling and to ridicule, and it's working. I mean, people are staying away from it. So one of the main reasons why I'm out here is because it is being censored, and they're doing it through ridicule and not taking any of this serious. They don't even talk about this curvature. I don't think you guys have ever seen this before, have you? No, exactly, right? They don't teach us this in school. It's the first thing they should teach us if the Earth is truly a globe. You know? Are you guys familiar? Are you guys good with basic math?
Yeah.
That Pythagorean theorem, a squared plus b squared equals c squared, right? So since we understand that calculation works, right? Since we are telling us the radius of the Earth and we know the distance we're observing, we can do r squared plus l squared to equal x squared. Once we solve for x squared, all we have to do is deduct the radius, and that leaves us with the drop. So this is another formula that's over 99% accurate for the first 300 miles. So this 8 inch per mile squared, you know, you can't escape it. You know, you could say, oh, well, the Earth is twice the size they're telling us. It's just much bigger, right? Let's say it was 50,000 miles in circumference. Half of this curvature should still be there. But in reality, water is not even gonna curve an inch. You know what I'm saying? You could say it's 1,000,000 miles in circumference. There still has to be curvature. You know what I'm saying? So again, water is the #1 proof to debunk the globe. You know. So I do have some information here that you guys could take to cross-reference. And these are the 6 main proofs to debunk the globe. If you want to take a look at them, and if you guys have any questions before you guys go, that would be great. You know, I can answer any question you may have. You guys can take one each.
Yeah, so then what do you suggest the Earth is then?
So the Earth is a level plane. The reality is nobody actually knows the dimensions. So here, let me just show you a quick map. And I'm pretty sure you've seen this map before. Let's see. I have these cartoons right here. So again, this is a cartoon as well. But if the continents and everything they're telling us is all there is, then this is what the Earth would look like. But if you ask me, there could be other continents here, another continent here, this continent could be bigger, you know. In other words, nobody actually knows the layout of the Earth. Another thing about this map is that they claim Antarctica is the bottom, is the ice sheet in the bottom of the globe. If Antarctica actually exists, if it does exist, it's the ring around us, and that's what's holding the water in, like a container. You know, it's containing the water, you know. And I think that's where the word continent comes from the word container, you know, the word continent. So the continents are containing the water. You know what I'm saying?
We suggest that it's in the end of
that's why I'm out here. I actually want people to become aware of this fact, and maybe we can actually explore. People think that there could be other ponds over here, other ice ponds. So our sun just rotates around. That's why it melts the ice, and that's why, you know, we have the water we have. So people think that if you go south this way, you're gonna find another Earth over here with its own sun.
Yeah, well, isn't that possible? Yeah, if you just walk straight north,
Exactly. I don't know if you knew this. There's actually an Antarctic treaty that prevents anyone from exploring south. Yeah,
Really?
you could look it up. Over 47 countries signed it already. So if you anybody that gets close to the south, 66 degrees south, you're gonna get stopped.
Really?
It's on paper. I don't know anyone that's attempted. There's actually one guy that supposedly has done it, and he got arrested. He didn't even get a jury trial, and he was just sentenced.
Well, what's the reasoning for like not letting people go in there?
So if you ask me, it's about control. So how does a farmer keep his cattle from leaving the farm? He does a fence. You think you could do a fence with human beings?
I mean, yes,
You can't.
it's possible.
You can't. Human beings always gonna try to climb that fence.
Right.
You know what I'm saying? So how do you keep a human being from exploring? You tell them you're leaving a ball. So that ball is your fence. Your mind. You know what I'm saying? Because we don't know how big this Earth is. We don't know if there's other ponds over here. You know how many other civilizations. There's probably other civilizations that are actually way more advanced. That actually live with free energy. Because free energy is a thing. I don't know if you guys knew the first law of thermodynamics. Energy cannot be created nor destroyed. It can only be transformed from one form to another. That theory, that fact alone also debunks the Big Bang theory, because the Big Bang claims that everything came from nothing. You know what I'm saying? But the first law of thermodynamics debunks that. You know what I'm saying? Another thing about the second law of thermodynamics is high pressure always moves to lower pressure. So if you have like a gas tank that has very high pressure, what happens when you poke a hole?
It goes out.
Exactly. Air always equilibrates. So this idea of outer space next to the Earth's pressure without a barrier, it doesn't make sense. The second law of thermodynamics, everything has to be, you know, sealed in order to have pressure. You know what I'm saying? If you don't have a barrier, the high pressure will always move to the lower pressure. In other words, our atmosphere should be getting sucked by outer space right now. So if you ask me, I don't know if you guys heard of the dome theory. You know that the Earth might have a dome?
Yep.
That theory is way more viable than the outer space theory. Because outer space, again, the second law of thermodynamics debunks it. You know, we have to have a barrier keeping our air from escaping. You know, that's how we're able to breathe.
Wait, how does the, like, not the flat earthers,
Yeah.
or like the normal, like, no, not normal, like no kind of people,
Yeah.
how do you assume or like assume that the air is like trapped inside and like the pressure doesn't leave? Like,
Well, the fact that we have air pressure, I would say that's a more logical conclusion to come to. Obviously, it hasn't been proven. So if you ask me, it's one or the other. Either the air is being contained and the Earth is limited, or the Earth is infinite. It's one of the two. It's either the Earth is infinite, or there's limits and it's being contained by like some kind of barrier.
Yeah.
We're in some kind of
I have
enclosure
a
here.
question then. For
Yeah.
example, like when you fly from one country to another,
Yeah.
for example, like the U.S. and like Japan is like opposite sides, right?
Right.
So like for example, if it's this map, then the plane like usually it'll show that you go like around like this, right?
Exactly. Yeah.
So but the shortest path would be like to
A
go
straight
straight,
line.
right? But then so you're saying that they purposely go around like this just to show.
So when you're in an airplane, you see a projection, right?
Yeah.
Usually, that projection is a globe projection.
Yeah.
So in reality, you are flying in a straight line like this, like that, like
Okay.
that. But in that projection, because it's a globe projection, it's gonna look like a curve. You know what I'm saying? What you're seeing in your airplane, in your screen, that GPS, again, it's gonna show a curve because it's a globe projection. But in reality, you do fly in straight lines because the shortest distance from 2 points is a straight line. And to save fuel,
Exactly.
you're gonna go in straight lines. You're not gonna be going around. You know, that doesn't make any sense. So another thing about airplane flights, they only go east and west. So circumnavigation only happens east and west. But on this map, east and west are only circles.
Yeah.
East will be this way. No, this will be west, and then this will be east.
Yeah.
So if you go south, again, you're gonna hit Antarctica.
Okay, but for example, from flying from New York, and this is Japan, right?
Yeah, Japan.
So you're saying that we have to cross the North America to go to the Japan, right? To go, right?
Again, I would say, because you're gonna be like, oh, but in reality they don't fly like that, right? Again, we don't know the true layout of these continents. So if a flight doesn't make sense, it's not that the Earth is not flat. It's just that we don't know the layouts of these countries. The reality. That's the reality.
And wouldn't pilots know about that then?
I don't know if you knew, pilots don't even know how to navigate. They only follow GPS nowadays.
But the GPS knows.
Yeah, exactly. Pilots admit to this. That all they do is just follow the route that they're given, and that's it. Yeah, all they do is literally just land the plane. That's truly everything. You know, pilots don't really have knowledge anymore like they used to back then. You know what I'm saying? Same thing with sailors. You know, I would say sailing takes a little bit more knowledge still, but they all use GPS now. You know, back then they used to use sextants, and they used to use the stars, and they used to use, you know, instruments, you know, physical. Now they just use GPS, electronics. You know.
I have two questions.
Yeah.
So first, this one.
Yeah. Okay. Yeah. It's like diagram theorem.
Yeah, up to 300. Why is it up to 300?
Because let me show you the other curvature. So this is the exact curvature rate. So the exact curvature rate measures the curvature all the way down, because it measures the whole ball, right? This one, the Pythagorean theorem, we're only measuring using triangles, so it can only go so far out, and it has to go back in. So it doesn't go down this way. So we're not measuring the drop this way. We're just measuring it going this way back in. But because it's still there and it should still be measurable, it's accurate for the first 300 miles, because then this starts to curve down more. And again, this line doesn't keep up with that curvature down here.
I see.
But this one will be the exact. This one does keep up with that. It takes account for the whole thing. So that's why this one's only accurate for the first 300.
Yeah.
So you're suggesting that all the other planets that people like. You know,
I'm glad you brought up the planets.
Yeah.
So the stars, right? They tell us that they're light years away, right? And they're trillions and trillions of millions of miles away, right? So these images of the stars were actually taken with a P900 camera. Have you guys heard of the P900? It's an 83 times zoom camera. It's the most powerful zoom camera on the market. And it's digital zoom. I mean, it's optical zoom, not digital. So it's real zoom. So if you ask me, we shouldn't be able to zoom into the stars this much and bring them into focus if they were truly, you know, light years away and millions and trillions of miles, because it's only 83 times zoom. If you ask me, the stars are only like a couple thousand miles in the sky, you know, maybe 3,000. Who knows? I don't really know. The reality is nobody knows what these lights are. So these are what the planets look like. So this is what NASA shows us, a cartoon, but in reality, that's what it looks like. So they look just like the stars. I don't know if you knew. And then we could bring them into focus with the same camera too. That tells us they're both in the same spot in the sky, like around the same distance. So I don't know if you knew, they used to be called wandering stars. The planet, that's where the word planet comes from. And the reason why they were called the wandering stars is because these other stars, they're constant. I don't know if you heard of the constellations, right? The stars, they always reset every year. You know what I'm saying? These other, the planets or the wandering stars, they're not fixed with these other stars. They have their own unique paths, but they still reset every year. That's the only difference. These are fixed and these are not. But they're just stars. They're just lights in the sky. Nobody really knows what they are. You know? In my opinion, 20 miles is the highest human beings have ever gone. So anybody showing you images or anything higher than 20 miles is either cartoons or CGI, or it's not real, basically. You know what I'm saying? So these images were taken with amateur helium balloons that people have. There's hundreds of videos of people doing this. And again, 20 miles is the limit that balloons could go. You know, have you guys seen the Red Bull jump by Felix, done by you know how Red Bull they do stunts? Yeah. You know what I'm saying? It's actually, you guys could look it up. It's called the Red Bull jump, and he actually went up with a giant helium balloon too, and nearly 20 miles this high, but he used a GoPro. So he was trying to fake that he was seeing curvature, right? But it's clearly a GoPro. You know, if you see the video, and he jumps from that high, and they call it the jump from space or the edge from space, right? But to me, that's the highest humans can go. And he wasn't even near, you know, what they claim space is. They say space is over 200 miles. So 20 miles is not even close, you know what I'm saying? But yeah, 20 miles is the limit, you know, in my opinion. You know, that's the highest humans have gone. So in my opinion, the heliocentric model, the ball Earth with outer space, it's just a religion. And I'm gonna tell you why. What do all religions have in common?
We don't know if it's true.
Well, that's one thing. And another thing, a creation story. Every religion has a creation story. And what does the heliocentric model give us? The Big Bang, evolution, you know, all this other bullshit, you know. And again, that's just a creation story. That's not true. You know what I'm saying? Just a religion. Just like any other religion, you know, has their own version of how we came to be. The reality is, we don't know how this thing came to be. Nobody knows. As far as I know, nobody knows. You know, so we don't know what we're experiencing here. For all we know, this could be some kind of technology that we're experiencing. You know, I don't know. I'm out here trying to find out. Why are they lying to us, right? Why is this? You know, why are you lying to us about this place and what there could be? You know, so all these things about aliens coming from above. If aliens do exist, they're across. They're on another Earth. You know what I'm saying? So there could be other alien humanoids that look like us, that could be more intelligent. You know what I'm saying? So us thinking that we're like, oh, the most intelligent mammal, we might not be. There might be another more intelligent being that exists here. Who knows? I don't know. You know what I'm saying? But I think exploring the Earth, if once everybody becomes aware of this, because we have the technology now with the military. If you ask me, the military is for sure exploring this place as we speak. Where do you think all our tax money is going? Like the military is like a black hole budget. Like what the fuck are they doing with all this money, right? You ask me, they're exploring this place. They're trying to find out how far they could go this way, and maybe they came across other civilizations. You know, who knows? We don't know that. They're not gonna tell us. You know what I'm saying? There's so much secrets going on in the military with black ops and all this other bullshit. Like they have operations, you know. Who knows what they're doing, you know, with our money? Because they're using our money at the end of the day. You know what I'm saying? All the tax money they take is crazy. You know, so I'm hoping, you know, that this blows up like how it should. Because obviously, it blew up on the internet in 2018, 2019. But that's around the time they censored it. And ever since then, I'm seeing that kind of slowed down a bit, you know. People, you know, kind of are not looking into it, like, and again, because they're not coming across anyone like me. So it's one of the main reasons why I'm out there, you know, trying to share this, you know. So, I mean, any other questions you guys may have?
No, I think it's a unique, like, other way to perceive how the Earth is like theorized.
Are you saying like, is there another way?
No, like there's two types that way I really know about, right? Like the
Alright.
globe method and the
Yeah,
method
so
used
I would
to-
say the globe obviously is a theory, but water being level and the oceans being level, and I would say that's not a theory, because, you know, physics is what it is. It's up to us to experiment and determine, you know. But again, physics is what it is, and we can only discover it. You know what I'm saying? It doesn't require faith.
Yeah.
And water being, you know, it's right here. We can test it, we can measure it, you know. Doesn't matter, it could be in a lake, you know. If that curvature is there, we should be able to measure it, you know. And in reality, you know, water's not gonna bend. You know, water doesn't.
Yeah, actually, I have one more question. Can you show me the this diagram again?
Yeah.
Right. So if this is what, like, you know, Earth could look like, you know how like other depending on which continent you are, it's
Yeah.
like the seasons change, or like the temperature
Right,
is different,
right.
right? Then how if it's just flat, then how do they adjust
The seasons, how do the seasons work, right?
Yeah.
I'm glad you asked that question too. So the sun is not what they told us, right? So they tell us the sun is 93 million miles in diameter, or 93 million miles away and 500,000 miles in diameter, or so, right? But in reality, here, I can show you these real quick. Have you heard of crepuscular rays? So these rays, when they're coming through the sun, you could view next time that there's not cloudy like this, you'll see the rays coming in at an angle like this.
Right.
So in other words, if you triangulate these rays, it'll show a very small local sun. And people have measured the distance using triangulation to the sun, and they estimate, they did this back in the day, I haven't done it myself, but they estimate the sun to be only 30 miles in diameter and about 30 miles to 300 miles in the sky. So it's a very small light. So in other words, when it's our summer here, think of the sun like the diameter of this line in comparison to the Earth, right? And think of it like very close to the surface as well. It's not gonna illuminate the whole thing. So it can only illuminate like about half of this plane, you know, but a very small local sun. So what happens is when it's our summer, the sun's doing a small circle around the north, a very small circle. Right now that it's winter, the sun's actually doing a bigger circle. So that's why in the summer the sun's higher in our sky, and in the winter it's lower in our sky. And if you ask me, it's just because it's further away. So that's what causes the seasons, the movement of the sun going in and out. And that's why Australia has an opposite season than us. When it's summer here, it's winter there. And when it's summer there, it's winter here. Because again, the sun can't be in two places at once.
Right.
You know what I'm saying? So that explains the seasons. Again, it's not proof, but it's just the most logical conclusion. Yeah.
Makes sense.
Yeah. So again, the water's not a theory. This could be a theory.
Okay.
Yeah.
That's interesting.
No, yeah. I'm glad you guys. Am I the first person you come across that's a flat earther, right? Or
I guess, yeah. Like a person that's actually, like, you know, with actual proof, like physical proof.
yeah.
Yeah.
Yeah. So you've spoken to other people like about this subject before?
I mean, I've heard of people. I know people that are of like flat earthers that don't know, they can't back up their like physics.
I see. I know what you mean. People
But-
that can't really explain it or know how to articulate it,
Yeah,
right?
yeah.
Or just say, oh, go watch this video, or go watch this link, like, you know. Yeah, that's not good, because again, a lot of people want the proof. People want to be proven wrong. And I feel like that's what I'm doing here, you know. And again, I want to be proven wrong if I'm wrong. You know what I'm saying? I don't want to be wrong, you know. So if I am wrong, what better place to come, right, to be corrected, right?
Right.
Than a university. No, but yeah, but I'm glad you guys did stop, you know, and had a chat with me. Do you guys have any other questions before you go?
This is
No?
very interesting, yeah.
No, yeah. I'm
like
glad
it.
you guys did stop.
I like it.
So here, I don't know if I give you guys my channel. I go to other universities as well, and that's the first one on there. You guys could check it out, and you guys will probably see yourselves on there, you know, in a few days.
Maybe.
Yeah.
I'll check it out,
Yeah, thank you, man. Appreciate it. You guys
Yeah.
have a good one.
Good luck.
Yeah, thank you.
Sure.
Oh. Thanks for talking. Have a good one.
Thank you.
I think they forgot something in it.
What's up? So you guys want to give it a shot
Okay.
to see if you guys trust your common sense?
Yeah. Okay.
All right, cool. So 3 very easy questions. See if you guys could get 2 of 3.
Okay.
So I have 2 images here. The first one's the hardest, by the way, and they get easier.
Morgan Freeman.
No. So the question is, I have 2 images, and the reason I call them images is because one of them's a photograph and one of them's a painting. So I want to see if people can tell the difference. Which one's a photograph? Which is a painting?
That's a painting. Painting. Photograph. You said there are 2 images. One's a painting, one's a photograph. I feel like I don't know. Can I pick this up?
Yeah, pick it up. You can even guess if you want.
Probably this is the painting.
Okay. It was actually a trick question. They're both paintings. Yeah, so I don't expect people to get this one. Obviously, I couldn't even get it. But
That wasn't
they're-
common sense though.
No. The next 2 are. This was just a start to get you warmed up. There is 2 reasons why I asked this question though, because it does have to do with the subject I'm
What
talking
about
about.
this image right here?
And what about it?
Is this a painting or a...
I don't know. If I'm being honest, I don't know. So
All right, what's the next one?
there is 2 reasons why I asked this question. Just believing someone opens the door to being deceived, right? Because
Yeah.
you guys believe me, that influences your choice. The second reason is if we want to determine something is real, an image is not good enough.
Oh, and it's also called like an anchor. You told us like one of these, initially you told us one of these is a photograph.
Yeah,
one of
I
these
lied
is-
to you.
Yeah, and so that initial anchor like caused us to believe like,
Yeah.
like make that
Yeah,
decision
actually,
that one
I've
of
had people actually tell me that they're both photographs. They don't believe me, so they say, "Oh, they're both photographs." I don't believe you. So that's my point. Is that just believing? You know, you shouldn't believe someone. You know, and you did. You know, that's my point. The second reason is if you want to determine something is real, an image is not good enough because if I showed you an image of me flying or me walking on water, would you believe I could do those things? No, it's obvious, right? That defies physics. Yeah. So these next 2 have to do with elementary physics with water. So could we agree that water always seeks its lowest point once contained, especially? In other words, it always goes down. Because I could turn the bottle upside down, but water always goes down. That's a fact of water. It always goes down, right? So since we understand that fact about water, I use blue food coloring for this to make the water blue to make it easier. Since we understand water always goes down, how I'm showing you these, which one of these 2 is upside down? Which one of these 2 images? Since we understand water goes down, which one of these 2 is upside down?
You mean upside down.
Yeah, okay.
This is the ground, right?
Well,
Well, it's supposed to be the ground on both of them, right?
Supposedly, but
Okay,
I'm
this
try-
is not this is not real.
no, which one's upside down?
Well, this
you're,
one.
You're overcomplicating
I
it.
don't understand.
You understood it, right?
It's that one.
Yeah, it's this one, yeah. You got it. Can you explain to him why? Or you need me to explain it?
Well, I mean, the water goes to the bottom.
Exactly. The water can't stick to the top of the bottle.
Isn't that what I? Okay.
Yeah, so I took this one like that. So this one was upside down, how I was showing to you. Right, that's obvious, right? This last one's very easy, you know. Have you guys ever heard of the term water finds its level? You know, water always finds its level,
Okay.
right? Could we agree? Like, for example, when you fill up a pool, what would be another word for level if we had to use a different word?
Like the water's just like undisturbed, like it just like
Yeah.
it just settles in it.
Yeah, what could be another word for level, though? If we had to use to
Even?
describe that.
Like even.
Even, that's a good
I
word.
guess the water surface would be uniform or something.
Uniform, horizontal is actually the proper definition of level, you know. So you guys are close. I mean, so since we understand that fact about water as well, you know, it always finds its level. Which one of these 2 represents level correctly, A or B? Okay, perfect. Yeah, you guys got it. So the real reason I do this is because over 95% of the population, including myself and maybe you guys, have been tricked to believing this is the answer, even though we know it's this one. You guys want to know how we were tricked? You guys believe the Earth is a ball?
The Earth is round.
Yeah, a ball, a sphere.
Oh,
Yeah.
well, it's within reason. It's not perfectly spherical, but I
So
do
you think it's a oblate spheroid?
something.
So you think it's the sphere regardless, right?
Yeah.
Yeah. Okay, so NASA in
It's
specific,
round, that's
right?
right.
That's what you think. Okay, so NASA in specific, they claim to have satellites orbiting the Earth, right? So they need to know the radius of orbit. So they need to know the radius of the Earth if they're truly going around it, right? So they do tell us the radius of the Earth is 3,959 miles. So if we multiply the radius times 2, we get the diameter, right? And if we multiply the diameter times pi, we get the circumference. So the circumference of the Earth is 24,901 miles, what they're telling us. So there needs to be curvature every mile. So the first mile is an 8-inch drop, second mile 32 inches. By the third mile, there should be 6 feet of curvature. So in 10 miles, there should be 66 feet. That's a 6-story building. So if we actually went out in nature, like a giant lake that was miles across, and we build a level structure over it to measure for this curvature, the water is going to show us that it's level. In other words, it's going to be parallel to the structure. That's what level means. That's what water does.
But like you were like.
But they're telling us this is what water's doing.
Okay, and so like you were saying that like we can be deceived by things.
Yeah.
Then how about you actually build this level structure over the ocean and show me that there's no curvature, and I'll believe you.
So
because I can't believe something else just for the sake of not believing the other.
Don't believe me. So this structure is going to be better if we build it over a lake, and there's a simple reason why. There's no waves, the water's not really moving, and then the depth, we're going to need some pillars to hold the structure. So,
Okay,
so a lake will be more ideal.
And how do you deal with the problem of like we said, the Earth isn't completely flat either. There's valleys. There's
Exactly. That's why we're measuring water.
But wouldn't the bottom thing have to be flat too?
No.
Well,
so,
no. You
yeah,
you explained to us.
We're building the structure.
Okay.
So you know what a plumb line is? You ever seen a plumb line? It's a weight with a string attached to it, right? That's considered a downwards vector. I don't know if you knew this, but in construction, all downward vectors are considered parallel. So what that means on a globe, all downward vectors are not parallel. They're all coming to the center. But in reality, all plumb lines, all downward vectors are parallel. Doesn't matter the distance.
Okay.
So if we construct 90 degrees from a plumb line, we're always going to be horizontal.
Okay.
So that's what the structure is going to be based off of, a plumb line.
Okay.
So the water should be bending from that structure. But again, you're saying let's build this structure. Well, that's why I'm out here, because this information is actually being censored from the internet since like 2019. So nobody's talking about this experiment. You know what you're going to see online? You're going to, on the mainstream especially, laser experiments. Oh, look at the lasers bending. It doesn't.
If I can explain something to you real quick,
Sure,
I'm taking
sure.
a geology class,
Okay.
and this whole entire concept is
Okay.
like really like something that we're focusing on,
Yeah.
especially like now. And I don't know if you're familiar with the Wella Sciatica, but that's basically how the Greeks determined that the Earth had a spherical shape because the way that the sun cast its shadow down, like
Okay.
at one point on the Earth, and they measured the degree from like.
Yeah.
From that point, that well at midday when the
That's-
sun would shine all the way down, they measured that to another city, and the degree was 7 degrees, and like all the mathematics does check out. And
So-
with that in mind, like what could you say to refute that? If
Yeah,
what you're saying is
easily,
true?
easily. All of that is done on the assumption that the Earth is a globe already. So they're measuring for the circumference. They're already assuming it's a globe. They're not measuring the curvature.
But don't you think that because of solar eclipses and lunar eclipses, where we can clearly see the curvature of the Earth being like projected onto the moon by the sun, the shadow, like it shows a curvature.
Okay.
And so like,
Yeah, so-
and also
okay.
like we can observe that the sun and the moon are roughly
Okay,
spherical,
real quick,
right?
and I'm going to address all those points in one. Anything to do with the luminaries, the sun, the moon, the stars, in reality, nobody knows what they actually are and where in the sky they are. So we don't know the distance to these. They're all assumptions.
We do. Look, do you want me to show? I can pull out my homework, bro.
Sure,
I can-
show me.
No, I actually had to do this for homework.
You're going to just show me scriptures
Nope.
like a Bible, but it's fine.
I'm not gonna show you scripture. Oh, but I guess like.
Yeah, I mean, you're not going to be able to show me how they measure the distance to a star.
Look, I got you.
Yeah, sure. Yeah, I would say anything about the sky to measure the Earth is a red herring, because it's not a physical measurement of the Earth. So it's a I don't know if you guys know what a red herring is, but it's a diversion basically.
Cosmology and planet.
Yeah, trust me, I've seen everything you're gonna show me. You're gonna show me some scripture of how they supposedly
No, I'm
measure
not.
the distance
No,
to
I'm
the
not.
sun.
I'm not.
I mean, if you know this, can you just explain to me how they measure the distance
Well,
to
it's
the
like
sun?
I want you to actually see it so that it's
sure,
not
sure,
like
sure,
me.
sure.
Like you
Show
showed
me.
me diagrams.
Sure,
and
show me.
Alright.
I would love to see it.
I just don't remember exactly. Video about the Greek philosophy of time. No. Where's 7, bro? Oh, here it goes. Video of relative sizes of moon, sun, and moon. Video of actual size of moon.
And you're not gonna show me CGI, right?
like, just watch a video.
Yeah, sure.
Videos of absolute sizes, videos of relative. Okay, I just.
Right.
Of 5 videos about the sizes of the Earth, the Moon, the Sun, and their distances from us. And now we're going to discuss the relative distances between the Moon and the Sun. We already know from the pattern of a solar eclipse that the Sun
Okay,
is
I would say this is an assumption already. How did they determine that the Sun is further away than the Moon? They're already making an assumption already from the back.
No, there's previous videos. Like, it's just I didn't want to run you through the whole series, bro. Like, there's a total of 5 videos. That's why. And you,
Well, show me the first one. How they determine the distance
video.
to the Sun.
The first one's called the video on the size of the Earth.
Okay. Well, we're talking about the luminaries or the Earth. We're talking about distances to the luminaries, or are we talking about shadows on the Earth?
It covers the size of the Moon, the size of the Sun, and the size of the Earth, and how that we derive those. And like, it actually makes sense, bro. Like, I'm not one to believe I'm not one to believe in things that aren't backed up, but like,
I mean, water being level, it's in our reality. We could physically measure it. I mean, I would say even if that's true, we should be able to measure it then. And I would say NASA should invest. They get like over $60 million a day, NASA, right? They could use $1 million of that budget to prove that the Earth curved. They could build this level structure over a lake that's 2-3 miles across and prove that the water is bending. With $1 million of their daily budget, they get over $60 million a day. Why haven't they debunked flat earthers already? Why haven't they built this structure to debunk us?
So you're saying the Earth is flat?
It's not flat because obviously there's high points and low points, there's valleys, there's canyons. It's level. The Earth is a level plane.
It's
and
not
flat
a sphere?
Earth is not a sphere, 100%. Why? Water shows us that. Physics shows us that.
Then what do you have to say to
Well, like I'm saying, like, you've never
actually
actually seen the structure, not even yourself, and you're explaining to us that the reason, the premise that you're like you using to support your beliefs is based on
Well, it's
something
not a belief, it's a
you
knowing.
that you haven't never seen this. You have never seen this.
I've seen
actually-
water. Have you been to a lake?
Wait, so what do you have to say about like satellite pictures of the
I don't know
Earth?
if you knew,
and-
NASA doesn't call them photographs, they call them images. You want to know why they
Hey,
call
so
them
what if-
images?
Oh, so that's why you showed us the pictures earlier?
Hey, so
Exactly.
what if
you want to
they-
determine something is real, an image is not good enough.
Hey,
And
so-
they call them images because they're Photoshop. They admit to them. They call them
No,
composites.
a photograph is from like an actual like photo
A snapshot.
camera.
Yeah, they
Can I-
actually.
can I ask
What
you a
they use
question?
in space. You can't take those kind of pictures in space.
They say they take different strips of imagery. So they say they take hundreds of different pictures and they stitch them together.
Hey, can I ask you one question?
Sure. It's
If
so
if they were to put you in a rocket ship right now and take your ass to outer space, and you fucking went to outer space and saw the Earth round, like, would you still be telling us this? Do you think?
This one's gonna make you probably walk away. I don't know if you knew this. Outer space is just a concept. Did you know that?
And how can you prove that to me?
I mean, they admit it's a concept. It's just
But
an
you're
idea.
believing on they? Who's they?
No.
Who's they?
The experts that talk about outer space and the distances to stars and the distances to sun, they admit it's just theory. Everything, all the calculations they're making, they're just
With
theories.
the theories that are grounded on like actual observation.
On a belief
like,
that the Earth
it's-
is a ball.
Like
That's what the
it
theories are grounded
requires
upon.
like a lot of deductive reasoning and like I don't know, man. It seems pretty solid. Well, compared to this, like,
You guys want to know what the stars actually look like? Have you guys ever seen the stars through like a
did
real
you take
camera?
this picture?
These, again, there's actually have taken pictures like this, but I didn't take these in specific because obviously we don't have clear skies here in the States. But these are using a P900 camera. Are you guys familiar with that camera? It's a camera with 83 times zoom, most powerful zoom on the market right now. And basically, this shows us that these stars are not trillions and light years away like they tell us. We shouldn't be able to bring them into focus like this if they were, if they were light years away, supposedly. And then
But the way that like
this is
the
what the-
physics of light works is like it takes time to travel that distance. And
Yeah, that's what they're telling us. But again, we shouldn't be able to bring them into focus. Is my point. They should still look
And why
like
not?
because they're too far away. This is only with 83 times zoom.
Yeah, from here.
Yeah, from here.
Yeah, but the pictures of other stars that we've seen are like from satellites that are in space, so they're way
And so, do you think that the James
Okay.
the
Way
James
less
Hubble
light pollution.
the James
Yeah, any-
Hubble telescope? I mean, what is it
If-
called?
if-
James Webb. I mean,
Yeah, any
Hubble.
telescope or
Sorry.
satellite you see, if you Google right now satellite in space, if you pull out your phone right now and search satellites in space, they're all gonna be cartoons. They're all gonna be CGI. So nothing over 20 miles, in my opinion. Nope. Human beings haven't gone over 20 miles. 20 miles is the limit.
What about like,
and that's an
like,
opinion.
Yeah, it is my opinion.
yeah, we.
Yeah, it is my opinion. But I
Do you
guarantee
think the
you
moon
any-
landing is fake?
Well, the moon land again. it's obviously fake. If you've never looked into like the videos, like it's just ridiculous. Like you could literally see the.
You actually like believe this?
Like actually.
It's a fact. Water shows us that.
Well, it kind of sounds low-key like an opinion backed by like a
Well,
vague sort
the
of
physics
like,
of water is not an
Facebook.
opinion. The physics of water is not an opinion. You think the physics of water is an opinion?
Well, like, not that. I just think that your understanding of how it actually works is probably a little bit different from how. Because, like, I'm telling you, you have
Do you want
never.
to come out to Glenmore,
this-
get my pen, and talk about this some more?
I mean, sure. Yeah, you could have my. Here's my thing.
I think it doesn't matter if the Earth is round or flat, as long as there's weed. As long as there's weed
I
on
agree.
this planet,
I agree.
like,
But that's the thing.
don't even matter.
Because we
You wanna go
believe
smoke?
experts. We could be having more
Bro,
weed.
do you want to go smoke and talk about this
Yeah,
once
do-
we're high?
To be honest, I'm a little busy right now, but you could take my card. You know, you could.
What if we came back with a pen?
I'm okay right now. I actually don't like smoking when I'm doing this. You know, I like to keep my mind straight. You know, especially if people
Alright,
have
man.
questions.
Well, we were on our way to go do something, so we're gonna bounce now.
But here's my card. My card's in here, and these are the 6 main proofs that debunk the globe. You guys
Okay.
can check them out.
Thank you.
Did I give you one?
no, I'll use this.
Use this? All right, cool, perfect.
Alright,
man,
see you
yes,
later,
have a
man.
good one. All right,
Have a good
man.
night.
Have a good one.
Hey, bro, did I leave my sign here?
Yes.
Thanks for that, bro.
There you go. Man.
Also, did you record us?
I'm actually live streaming. This one's recording me. Yeah.
Who's watching?
20 people.
20 people?
Yeah, you
Do
can
they
check out the
believe
video. Oh, everybody knows on this stream.
Knows?
Yeah, everybody knows. It's not a belief. It's a knowing. You know the difference
You
between a
just said it's your opinion.
No. My opinion was the highest human beings have ever gone. That's my opinion. The Earth being level is not. It's not an opinion. That's a fact.
Right.
You said that the highest
You
humans
go
have
here?
gone.
Have you guys seen the Red Bull jump?
Do you go here?
Wait, you said that the highest
go here?
point,
Wait, give me a sec.
the highest point that we ever reached was 20 miles.
20 miles. Have you?
So
got-
what about the top of like Mount Everest?
That's not 20 miles. Look it up.
I think it's like thousands of.
No. You're talking about meters or feet. Yeah, we're talking miles.
okay.
Yeah.
Yeah, that's cool.
Here, you want to take some info? You have
Why do
any-
you think the Earth is flat?
Because
Like,
of
what's
these.
your
These are the
reasoning?
6 main proofs why.
Oh, the 6 main proofs?
Yeah.
Okay.
Do you go here?
Oh no, I don't.
My boy. Mount Everest is the highest mountain in the world.
How many
at
in miles?
29,000.
That's like
35.
That's like 4 miles.
Oh wait, no.
20,000 feet is like
Yeah,
4
why
miles.
is it in meters actually? Hold on, let me put. Oh, never mind, because I put feet instead of miles.
Yeah, put miles. It's gonna be like no more than 5 miles.
But the moon is like
Nobody knows. That's the fact.
nobody's been on the
Nobody
moon.
knows. Anybody trying to tell you how far the moon is, what the moon is, what
You're
the stars are,
actually
it's
right
just
about
it's
that.
a
You're actually
religion.
right about that.
It's just a religion.
You're actually right about that. It's 5.5.
Yeah, there you go.
But still, that doesn't like.
That's the highest point on Earth.
See,
like
the moon is fake.
I mean, I'm not out here to make people look dumb or to try to get one
I
up.
don't feel dumb. Or
No.
look dumb. Trust
When
me.
I'm not out here.
in gravity?
So,
Oh,
real quick
God.
about gravity.
Yeah.
I don't know if you knew, it's a theory, right?
Sure.
Right?
So, do you know what a scientific theory is?
Yeah.
Like, there's a difference between just saying, like,
Yeah.
okay.
So, before I get into gravity,
Yeah.
I don't know if you knew. Well, obviously it's a theory. Second, my second point about gravity.
Well, we're using theory colloquially.
Right,
so
right.
when it's a scientific theory,
Right,
there's
so-
a lot of evidence to
So
back
before
it
I get into the gravity theory,
Yeah.
I must show you how I can debunk that real quick. So
sure.
they're telling us that the Earth's circumference is 24,101 miles. This is
Sure.
what NASA claims because they have satellites orbiting supposedly.
Okay.
So they need to know the radius of orbit. So
Sure.
they need to know the radius of the Earth. So these
Yeah.
are the numbers they give us. So there needs
Okay.
to be curvature every mile. So in the first mile there's an 8-inch drop. Second mile there's a 32-inch drop. By the third mile there should be a 6-foot measurable drop. So in other words, we should be able to measure that curvature on Earth like this. So if we build a level structure over a giant lake that was miles across, we should be able to measure this 6 feet in 3 miles. So if we build a level structure,
So-
in reality, we know water level means parallel to anything that's horizontal over it. So like you're saying, well, what about gravity? I would say gravity is a false argument. It's a red herring because even if gravity was real, we should be able to measure this curvature over a
Sure.
body of water.
Okay, so you're saying that gravity's a red herring.
It's a red herring.
Because there's no evidence for it.
No, it's a red herring when it comes to measuring the dimensions of the Earth. Because the
Well,
way,
sure, but
the way
do
into
you buy that gravity itself exists?
So do you know what they actually measured when they bring up gravity? Do you know what they actually measured?
The
In-
acceleration of an
Exactly,
object?
the
Sure.
rate in which things drop, 9.8
Yeah.
meters per second per
Yeah.
second. So in other words, they're not measuring a force pulling this down. All they're doing is measuring the effect of this dropping, which is the measurement of speed, distance traveled in a certain amount of time. That's
Yeah.
all they did. they're measuring the effect. They're not measuring the cause. So gravity, again, it becomes a faulty argument for many reasons.
Well, sure, but just if we presuppose the existence of gravity.
So we have to assume that it exists.
Yes.
Again, okay.
And so the reason for the presupposition, or quote unquote, what you say is a theory, is that there's extensive evidence that shows that it does exist. We just haven't proved it.
So the evidence,
I think you're using theory very colloquially, where when
they're using theory, I'm just using what they're using.
When scientists use the term theory, they don't mean the way we use theory in regular jargon.
Explain it to me. How do they mean it?
Sure. So in general, if we look at things like the theory of evolution or the theory of gravity, these aren't just still like supposed facts or just like supposed opinions, right? When something's accepted as a scientific theory rather than like a hypothesis, it's there's a level of gravitas to the title theory. I think when you say like we're throwing around the word theory, it's like it's unproven.
Okay,
right?
I would just say to you, what does me dropping this and measuring the rating which drop, how does that tell me curvature of the
you're
Earth?
not dropping it, you're just putting it on something.
Okay,
right?
regardless, this comes to the ground because of gravity, right, in your belief.
Sure, but if we're measuring like
how does
weight,
that,
for example.
my point is, how does this dropping show me measurable curvature?
There's gravity that's acting on the object even right now.
Okay, but my point is...
So it's not that it's dropping. It's that if we accept that there's like something that's working on this object right now, right? Then we can say that depending on where on the Earth, right, this object is feeling the attractive pull, we're going to see structures like this occur, right? Like this curvature.
Okay.
Now, this specifically, when you're talking about, we should notice this. Do you know like where exactly your
this could be done in any lake that's miles across. There's hundreds of different lakes.
That's not true because we're not in a perfect sphere, right?
No. But the water level should be. Obviously, the earth, the terrain is not even because obviously there's mountains, but the water is. They're telling us. You know how they're redefining the word level in mathematics? They're redefining the word level to mean equal distance from the center to the surface. So if you're 5 feet above sea level here, and 5 feet above sea level here, and 5 feet above in between, and you connect those, they're saying that curve means level.
Okay.
But in reality, level means horizontal. That's my point. And water is the #1 proof to show us that. I don't know if you heard of the term sea level.
Okay, so
I'm going with physics, not theories. That's my point.
Sure. So let's deal with the physics, right?
Physics, yeah.
So you're saying that with this curvature, we should notice this drastic change in curvature.
In 3 miles, it should be 6 feet. Obviously, this paper is not going to fit 3 miles, so it's not to scale.
No,
but the measurements should be there.
So
11 feet at the end of it.
Are you saying that this has never been observed?
It's never been done. This experiment has never been done, and there's a reason why, if you ask me.
Okay, I would suggest just do the experiment.
Yeah, I don't have the money to do this. NASA can easily do it. They have a $60 million
If
daily
NASA
budget.
released the data, would you believe them?
I don't need data. I need physical proof.
Sure.
Because data could be manipulated.
If someone did the experiment, right?
Yeah, if somebody did, I would accept it.
So,
a physical experiment.
If NASA released the results of that physical experiment, you wouldn't believe them, or would
no,
you?
I would go. I will believe it. If they actually built this level structure and physically measure the curvature they claim to go around.
Oh, so you want them to build a 1 mile structure?
3 miles, 2 miles, doesn't matter.
A 3 mile structure without any bend in it.
We have the technology to. We can account for if there's any, because obviously we have the technology with laser cutting over 99% accuracy to build this structure.
Here's an easy way to replicate this, right? If we just took a laser and shined it across a flat point.
So lasers, I'm gonna tell you why they're not good. What happens when you shine a laser in water? Does that laser go straight?
Sure, there is diffraction, but if you have a high-powered enough, high-frequency laser, the diffraction doesn't occur to a significant amount.
I mean, but it's still gonna be there. Refraction is always gonna be there because the air is always gonna be there.
Sure, I'll buy that. But if you had a series of sensors, and have the laser shine through, and you just pick the point where the most concentration,
I know.
the highest concentration of energy.
I actually have seen a lot of experiments done with lasers, and all of them are inconclusive. And if you ask me, those are the ones pushing the mainstream because they're inconclusive. They want people confused.
I don't know what experiments you've seen that are inconclusive.
There's one on Netflix that I've seen. There's a mockumentary on Netflix that I've seen.
I don't think it was a mockumentary. I think it was just a documentary.
I would say they were not genuine, in my opinion, but that's fine. You could believe that
I
they
think
were.
it's hard to
Let me just tell you this.
Yeah.
If the Earth is truly a ball or a sphere, whatever you want to
Sure.
believe shape it is, you
Some
know,
like oblong.
should we be able to
rotational
measure the curvature?
object. Sure. Yeah.
Okay.
I agree.
Fair enough.
Yeah.
Then that's basically where I'm at, and I think this experiment will say, we'll just put everything to bed, if you ask me.
Okay. So the thing that I guess we disagree on is we have, well, like different axioms of thought, but also the fact that this is the only thing that could prove it to you.
Not the only thing. Those are the 6 main proofs on there.
Sure.
Euclidean plane geometry. It's like the 4th one there. That's the geometry used to build everything that we see, from railroads that are hundreds of miles to bridges
So
that are.
the whole point of having like tension in objects, like bridges aren't like perfectly like.
No. What I'm saying is the blueprints, they don't account for curvature in the blueprints of any of these structures that we build.
Well,
it's all done from a datum line, which is a horizontal
the way it's
line.
accounted for
Sure.
large structures is that the object itself has a little bit of give that already accounts for it, right? So when we have like large structures, we don't go like, this has to be incredibly rigid and super strong, right? We go, this structure has a level of tensile strength that.
I will agree that the
accounts
bridges
for
have that,
elasticity.
but again, the blueprints which are used to basically construct this in a computer, basically the blueprints
I agree.
don't account for
So
curvature.
let's say we have a 3-mile structure
Right.
and there's a 6-foot difference, right? You don't need to account for it in the laptop, right?
But it should be there, though, is my point. Even
Well-
if you don't account for it, it should be there. If we build a level structure, the water should bend.
No, I'm not talking about this. Like for example.
Oh, so you're
like-
saying the structure is gonna bend with the Earth?
Okay, so
I don't know what you're
I'm
saying.
saying is, let's say we build a
Yeah, we
really
build it.
long structure,
Yeah.
right? The reason we don't need to account for it on a laptop is that it's negligible, right? It's the same reason
Well,
why
it's not
when,
negligible
when
because
you do
8 inches per mile squared. That's what the math is.
Sure.
8 inches
So
per mile
that
squared.
6-foot difference over 3 miles is negligible.
So 66 feet in 10 miles is negligible too?
So
That's in 10 miles is 66
So
feet.
how
It
did you-
increases every mile. The curvature increases every, because it's not a pyramid. They're not telling us Earth is a
sure.
pyramid. So it has to increase
for
every
the
mile.
sphere.
Yeah.
The curvature at every point is the same.
No, but it has to increase every mile because it's not a pyramid. It's not
You're
just.
saying that if you took something and extended it straight like this,
Yeah, this curvature
it
is not gonna-
increases every mile.
Yeah, this
Sure.
curvature increases because it has to come back around.
Yeah.
So that curvature has to increase every mile because it's not
Sure.
a pyramid.
I agree with that.
That's my point. So in 10 miles, there should be 66 feet. That's a
So
6-story
you're saying
building.
that if there's a 10-mile structure,
There should be
right,
a 6
that it
story.
should account for this.
It should be 66
But
feet.
if we do have a structure that's 10 mile long, we have like intermittent support structures.
Yeah. The
So then
support. These will
it
be like the
becomes-
support structure right
yes.
here.
So it becomes negligible.
No.
Because
So
of
what?
the elasticity.
No.
of the
So what we're
actual
doing is, you know
material.
what a plumb line is?
No, do tell.
So a plumb line is when you have a weight attached to a string and you
It
just let it go.
tells you,
Yeah, what down is.
What down is, yeah.
So a downwards vector.
It
A downwards.
gives you perpendicular to
Exactly.
whatever
I like where you're going. So I don't know if you knew this. All downward vectors are considered parallel to each other. I don't know if you knew that. That wouldn't
Well,
work
in Euclidean
in geometry.
yeah.
Exactly.
In
Which is what's used in
specifically-
reality. In spherical geometry,
okay.
that's not
What-
true.
So what's the argument here?
That the Earth is not a ball. In
Well,
physics,
he's essentially
and
saying
geometry
that if we
prove
take
that.
a level structure and we extend it,
because they're
at
telling
one
us the Earth
point,
is curving 8 inches
the
per mile squared. That's what they're telling
difference
us.
is going to be
So we should be able to measure that
significant to
curvature.
the point where it's like bothersome.
So what are you arguing that the Earth is?
Well, the Earth is a level plane, but nobody really knows the nature of this place. Nobody really knows what it actually is, but the Earth is a level plane, undeniably.
I think
Water
just
shows us that.
accounting for your own logic, right?
Sure.
If we build like a completely level structure,
Right. I
with
mean, that's
no tensions, right?
Right.
Maybe that's true. Now, if we, you're saying that we don't account for it in like computer simulation of bridges, for example.
Yeah, when they're
Right.
building, when they're making the blueprints for
Yes.
these any construction,
So
they don't
the
account for
reason we
curvature.
don't need to do that is because when we have a level plane for like a bridge, right? We're not actually just going like, oh yeah, we're going to assume that it's going to be a level plane at all times, or it's going. We just.
They actually do. That's my point. They actually
So-
do it. They don't attack. They don't account for any curvature. That's my point. That's why they
Okay.
use Euclidean plane geometry.
So you don't need to account for. Okay, it's like
You don't need to account for it if
have
it
you done
doesn't
like
exist.
a physics problem where you're basically simplifying an object to like a sphere and seeing the forces that act on it. So there's an element of simplification where you can get rid of all the extraneous fluff. We don't need to account for a slight amount of curvature over a long period of time, because the elasticity of the actual, like,
but that's the thing.
In terms of like a bridge, for example, right? Bridges like bend, right?
Yeah, that's obvious. But my point is the geometry used to build this bridge, when you initially start building
so
it,
let's say we build a bridge like a mile that way, right? And then there's a support structure. So it might bend a little, but it's like negligible.
No, yeah.
Then we have another one, still negligible.
So you're talking about a bridge. I'm talking about just a simple structure. So
sure, I'm giving you an example.
Yeah.
Right?
So when you're talking about this negligence or this weight that makes itself, that it doesn't fully sit straight, that's the thing. We're gonna have support pillars basically holding the structure level.
Sure. So if this was completely like hard to the point where it doesn't bend, right?
Yeah. That's
then
the whole. That's the whole point.
I do believe we'd notice this. Sure.
Yeah.
But we've not done this experiment, right? So what you've debunked or tried to debunk the statement of like what people thinking it's flat is, like you said, that in engineered structures, right?
Yeah.
In real life examples.
Geometry, basically. Yeah.
Well, not geometry. You tried to give me a real life example.
If we're talking about building, it's geometry is used.
Okay, sure.
Yeah.
But buildings, right?
Yeah.
Real life applications.
Yeah, sure.
So I was explaining why your use of real life applications to debunk the theory that the Earth is a spherical.
I think that's pretty
incorrect.
reasonable. Real life applications to debunk the theory.
Sure, and I explained why.
Applications that debunk your theory.
Okay.
Okay. First of all, would you agree that if you were on Earth and there were no obstructions, would you be able to see on forever?
No. So I'm gonna tell you why. No. I'm gonna tell you why.
The scale of diffraction is like,
No. Not only that. I don't know if you guys knew. If I was to hold this bottle and walk away from you, eventually it's gonna get so small to the point where you can't see it.
Because of the parallax effect. Yeah.
So it's not the parallax. I mean, you could call it that, but it's perspective.
Yeah.
I think at a point it's not worth arguing with flat earthers.
That's true.
All right.
I am engaging.
If I was to ask you guys, what's the number one proof that convinces you that it's a ball, physically? In physics.
Well, it actually goes all the way back to the Greeks.
No. Right now, what makes you believe that the Earth is a ball physically, using physics? So the constellations actually debunk the globe. I'm gonna tell you why. Because if the Earth is truly shooting through space, we should have a different sky every night.
We've got a flat earther here. Do you want to help?
Sure.
We have better priorities.
I don't think we're fast enough to notice that difference.
Oh, so you think we're not fast enough?
Yeah.
Okay. So you think that we're shooting through space, but you think the sky stays the same, even though we're shooting through space at I don't know how many million miles an hour they're saying.
No, I mean, over like hundreds of years, the sky has changed.
Right. Oh, that's what you believe. You read that.
If we look at like old paintings of the sky, for example, and then compare them to now,
but
we do see that there's an observed change.
So everything comes to a point. So that's why we can't see Paris from here or Mount Everest, because now, we have a limit to our perspective.
Let's circle back to
we don't have Superman vision.
If we look at old paintings, for example.
Okay, second point.
Second point I had
is
if you look at a boat,
it's the same thing. Going over the curve, it's the same thing. We have a limit.
It disappears from the bottom up.
Yes.
Not all at once.
Yeah, because the ground, it's closer to the ground. There's no walls on the side. If there was walls, then it'll disappear.
If you extend like a vector,
Yeah, you understand it. Yeah. Boats going over the horizon, it's just out of our limit of sight. That's it.
I mean, then we need the actual number.
No, and again, if that curvature is there, we should be able to measure it.
Account for it well, right?
We should be able to measure this curvature that they're telling us.
If we did the math on this, I suspect that the parallax effect wouldn't be able to explain the rate at which the ship disappears.
Again, visual observations to me are inconclusive. Anything visual, light, again, physical. Physical measurement is what's going to show us.
So you're not saying that the Earth is flat, confirmed?
No, I mean,
you're just saying
it's
that
level.
We don't know what it is. Okay.
I think based on physics and what water shows me.
Well, no one's built this, which you've told me
No.
before.
The irony behind this is if we actually built this structure, the water is going to show us if that structure's straight or not.
But no one's built a structure.
No, not yet, and there's a reason why.
This is what you wanted as conclusive proof.
This would be the number one
structure.
proof, but again, there's hundreds of proofs. Those are the 6 main ones, in my opinion. This is the number one, but there's hundreds of different proofs.
When we've talked about Euclidean geometry, for example, we did debunk it because we went over this
No, because they don't account for curvature. Now, if they did use curvature, they did account for it. Then
why they don't account for curvature. I feel like we're going in circles here.
No, you're explaining why they don't account for curvature, but the reality is they don't account for curvature because it's not there. you're trying to you're trying to do some gymnastics, mental gymnastics to accept that there is, but they don't account for it.
If you have like a different axiom of thought, right? Obviously,
you're going abstract now.
Yeah,
you're going abstract now. I'm saying with physics, you're going abstract.
Well, okay, you keep pointing to this, right? This hasn't been tried yet.
And there's a reason why.
Okay.
There's a reason why this hasn't been done, and only laser experiments have been done, because laser experiments are inconclusive.
Laser experiments.
So this is now getting into the conspiracy aspect.
Well, it's not a conspiracy. Water being level is not a conspiracy.
What incentive
it's a fact.
do people
Water
have?
always finds its level. It doesn't matter the distance. It doesn't matter the size.
What incentive do people have?
Well, the incentive to lie about this is, first of all, I don't know if you knew NASA alone gets $60 million a day just to show us cartoons.
Sure.
Second reason is basically just to control the population. Basically, because if you
Why
believe,
does it control? Like, what does it do?
Okay, so
let's say I believe the Earth is spherical. How is it controlled?
So how does a farmer keep his animals from leaving the farm?
They put a ring around. So
they put a fence, right?
What's outside of the fence?
So that's why I'm out here. I don't know. I want to find out. So if the Earth that they're telling us, the continents, it's all that exists, then this is what the Earth would look like. But in my opinion, this is not even what the Earth looks like. Why? Because there could be other continents here. This continent could be a different size. You know, we don't know what's over here. I don't know. There could be another pond over here.
So
I don't know.
What? I feel like if you're just going to assume that everything told to you is incorrect.
No. If I'm gonna believe, put it this way, I don't believe anything. I go with physics, because physics shows me what
So
is.
right now you don't believe it's a flat plane or a sphere.
I do know it's a flat plane, and I'll tell you why. A level plane, to be specific. I'm gonna tell you why.
So I don't think Euclidean geometry works, because we've talked about this.
No, it does work. You're just denying it.
Well, here. So I'm saying that
look at any textbook.
You should presuppose a maybe, because we were both able to create like really succinct reasons to explain it from both our worldviews, right? One is everything's
What's your
lie,
worldview? My worldview is physics. What's your worldview?
Also physics. See?
So we should be able to
Funny how that
physically
works.
measure that curvature then, right?
But no one's done that before.
I know. So
I
your
agree.
so your
we
proof
should be able to physically measure the
so
curvature.
your proof of the globe is that nobody's ever done this experiment, so that proves the globe? That's not a very logical stance to be on.
I'm saying that for both of us, right? It should be a maybe. I don't understand why you say it's completely flat.
Because I understand the
level.
physics of water. I don't have to believe.
But you haven't done this experiment, so you don't.
This experiment it would just be to put the nail in the coffin. It's just for the ones that don't understand water.
So give me an example of another experiment that helps prove this for you.
Well, it's not. This would be the number one experiment. The second experiment. Have you ever heard of? Let me see. Well, Euclidean plane geometry will be the second one for me because it has to do with measurement.
Like I said, I was able to explain it from the perspective of a spherical earther, and it was like succinct.
You're just saying, but how you explained it, you just said, oh, it's so minute that they don't account for it, and it's like, but then you go on and say, well, we should be able to measure it though. So
and
you're contradicting yourself right there.
Measure it, but when we're running a simulation of building a bridge.
No, but after the simulation, they actually get built.
Yes.
So you're gonna say that in the simulation is not accounted for, but then when they build it, they do?
Because the elasticity of the material, right?
So you're saying that
is able to account for it by itself. Because a bridge, like, I don't know if this
that's abstract to me. So
okay, let's contextualize it. You know how bridges bend, right?
Put it this, I understand bridges bend. Yeah, I get that. Okay.
So
what's
now
your point?
if you have multiple support structures that anchor the bridge at different points.
So you're trying to say that this is I'm not saying that this is going to be like a bridge. This is going to be built completely different.
Look, I think you're losing, like, you're getting lost in the
No,
sauce
you're getting lost.
Right?
A bridge let me tell you this. A bridge
thing.
is not going to prove either or. A bridge is not going to prove
That's
either
what
or.
I'm saying.
So water will.
I can explain it in both a spherical world, and you can like say it's a lie in your flat earther theory, right?
It's not a theory because water's level, but yeah, water's going to show us whether it's bending or not.
I think you're going in circles again.
I think you're going in circles.
I have to go in circles because I have to keep up with you.
I'm
sorry, buddy.
No. Well, you're going in circles.
He's got a point here.
What's his point? Let me see.
If you're going in circles.
No, what's his point?
Okay. So, with a straight, if you were somehow able to build a level surface, right?
Okay.
Gravity, right?
So you're saying it's impossible to build a level structure because gravity is always going to bend it.
Exactly.
Is that what you're saying? Is that the argument?
That's what you're meaning, right?
That was me debunking this structure.
Okay, let me explain that now. So the way we're gonna build this structure is, you know what a plumb line is, obviously. Yes. We're gonna build 90 degrees from that plumb line, which is always gonna be horizontal. So we're gonna stay, this is gonna be our reference point, the plumb line. Right. So we're gonna stay 90 degrees every block. So we're gonna make sure that level structure is
There's
level.
one problem. There's one
What's the
problem.
problem?
Gravity. This is physics. It points radially inward from a point mass, right? So if you have a point mass,
Right.
gravity points radially inward.
So you're saying the downward vector is the center of the sphere.
Yes, exactly.
But in reality, if you go look at your engineering,
Let me finish.
Go for it.
So in our Earth, as you go further, this plumb line, because it's pointing in the direction of gravity, is going to be rotating. So what you'll end up with is not level
You're not
at all.
understanding me.
You're not understanding
No.
me.
I understand you. If the Earth was a ball, the plumb line should change. But we're gonna stay relative to the first plumb line. That's what we're gonna do. We're gonna stay relative to the first plumb line, and that's how we're building. Fuck all the other plumb lines. The first one.
So then why do you have the other plumb lines?
They're not. These are just support structures. We're gonna keep this level structure 90 degrees from the first plumb line, so that it stays level, so that we can actually measure that curvature. Does that make sense now?
So, regardless of that, right?
Yeah, we stay relative to the first plumb line, and that's it. And build 90 degrees to that. Yeah. So that's gonna build a perfectly straight line like this, and we should be able to measure this curvature.
I agree, but this hasn't been done.
It hasn't been done.
I
but
would say that
if
we
it was
would
done,
notice
it would
this.
debunk the globe. That's simple.
How do you know that? It hasn't been done.
Because
See,
water will show that.
I think it's interesting how you're saying that we're the ones who are like, stuck into a zone of thinking, when you presuppose the results of an experiment that you haven't done yet.
Right.
Okay, well, I have to get to class.
Oh yeah, I'm glad.
Enjoy, guys.
Yeah, I have to get some homework done. What's your name?
Prahan. Nice to meet you.
I'm Mark.
Okay. What book are you reading?
Oh, this is Project Hail Mary by Andy Weir.
Do you want to take some information home? Maybe you want to.
It is fantastic. It is
all right.
Really good sci-fi.
All right, man. Have a good one.
Not as good as Anathema by Neil Stephenson, which is even better. But it's good. It's fun. It's interesting. Yeah.
Let's get out of his camera.
Oh yeah. All right, you guys have a good one.